Hello everyone, a very good evening to one and all of you. I hope I'm audible and visible. So let's wait for 5 to 10 minutes so that everyone can be able to join this session. I'm just waiting if anyone want to join so that we can join. Okay, so let's start the session. Hello everyone, my name is Pooja Verma. I'm PMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Syamal Kumar Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 12 live and interactive session on signal processing techniques and its applications. So I hope all of you have gone this week video lectures. There are only two lectures for this week, that is power spectrum estimation. The course content for this week is power spectrum estimation. So you can use chat box for asking and interacting. Otherwise, you can unmute yourself and ask your doubt. Okay. So what is a power spectrum estimation? So just we will recapitulate or go through some theory, then we will solve some questions which will be very similar to your assignment problems. Okay, so the power spectrum is estimated by simply computing the squared magnitude of the endpoint DTFT of a x of n discrete time signal and efficiently implemented by fast Fourier transform algorithms. So power spectrum describes the energy distribution of a time series in the frequency domain. So energy can be a real valued quantity, so that power spectrum does not contain any phase information. And the distribution of average power of a signal in the frequency domain is called a power spectrum density, or power density, or density spectrum, power density spectrum. And the power spectrum density is a real and non-negative function over the frequency that represents the Fourier transform of the autocorrelation functions of a wide sense stationary stochastic processes. And the area under the graph of the PSD is proportional to the power of the stochastic process. And the PSD is measure of the signal power contributed over frequencies within the band of width. That width is defined as df, that is centered on the frequency k into df. And the power spectral density is real, not a complex quantity expressed in terms of squared signal units per frequency units, and can be plotted as a single graph. And some of the information that contain the full discrete Fourier transform has been discarded from the PSD, and the variance of the original digitalized record can be computed from the integral of the PSD. So we will solve some problems based on that it is a real or a complex, and that PSD we will calculate, then we will able to see there and understand. So some properties of the PhDs are there. that power spectral density that is represented by here Sx of f, and it is a real and even. Okay, even means Sx of f must be equal to Sx of minus f, and the area under the Sx of that is PSD is the average power of the xt. So whatever the area under the this PSD, it is a average power of the xt, and it is also that the signal point at that zeroth position, Rx of 0, that is represented by this one also. And one thing of PSD and autocorrelation are the Fourier transform of the each other. Okay, Fourier transform is an autocorrelation function. Okay, and X of f is the average power density, hence the average power xt in the frequency band is distributed from like minus f2 to minus f1 up 1 PSD as x of f, that is frequency distribution of positive as well as negative side, plus f1 to f2 as x of f df is equal to 2 integration of f1 to f2 as x of f df. And the power spectral density is a non-negative function, that means Sx of f always must be greater than equal to 0 for all the frequency, range. Okay, and any S of f that is real, even and non-negative has a finite area can be a PSD function. Okay, so this is the some properties of the PSD. Now computation of the energy density spectrum for a deterministic signal. So how we can compute? So that is computed by a Fourier transform function. So already we know that if any sequence x n, that is the sampling version of a continuous time signal xa of t, where sampling rate is f of s. To obtain the estimate the true spectrum from a finite duration x of n, if energy of that signal is varies from minus infinite to infinite, xa of t whole square dt must be less than to infinite, and then its Fourier transform will exist in this x of f that is equal to minus infinite to infinite x a of t e to the power minus j 2 pi f t. This is a simple Fourier transform equation. And Parseval's equality, the energy of any signal is we will calculate using the Parseval's equality. So in the continuous or time domain, it is represented by minus infinite to infinite xa of t whole square dt is equal to minus infinite to infinite x of f whole square df in the frequency domain. And the x of f represents the distribution of the signal energy as a function of frequency, and it is also represented by energy density spectrum of the signal, that is s of f equal to mod of x of f square. Now next one is autocorrelation. So autocorrelation function basically measures the similarity between the signals. Either it's same signal or either it's a different signal. It measures the similarity between the signal and its delayed version of the signal. So autocorrelation of a signal is represented by this function r of tau, that is limit t is to infinite minus t by 2 to t by 2 xt convolution of xt minus tau dt, where tau is the delay parameter. Then estimation of the spectral content, that is a power spectrum of a random process based on a noisy measurements of the process that has a finite setup. So there are two methods of the calculating the autocorrelation, that is a non-parametric method and parametric method. Okay, so these are the some points I think which have been covered in the video lectures also. Now we will solve some problems. So first question is, the noise at the input to an ideal frequency detector is wide, then power spectral density of a noise at the output is. What will be the options? Whether it is a raised cosine, or option B is flat, C is parabolic, and option D is Gaussian. So what will be the possible answer? So detailed explanation already I have given here. So if the noise of the input to an ideal frequency detector is white, then power spectral density of the noise at the output is a parabolic function. Okay, so an ideal frequency detector is a device that responds linearly to an instantaneous frequency of the input signal. When a signal is white noise, that means which have a flat power spectral density over all the frequency range is applied to the input frequency detector, then output spectral density is saved according the frequency response of the detector in any case. Okay, so if here it is a given that the frequency detector is a white noise signal, so the input is white, so PSD is a parabolic shape as a function of the frequency. This is because of the detector's output increase with increasing frequency deviation. So that results a parabolic relationship. So mathematically it is represented by if input of a noise signal is SINF is equal to N naught constant for a white noise, it is then output PSD is S out, that is represented by S out F, must be proportional to F square. That represents a parabolic distribution. So that's right. Option C is the correct answer for this question. If input of an ideal frequency detector is white, that power spectral density at the output is a parabolic distribution or parabolic function. Okay. So moving to the next question. So here basically mostly questions are uh, currently theoretical. Then we will move to some questions based on a mathematical description. Okay. So now next question is power density is defined as a which function? Power per unit area. Option A is radiated, option B is reflected, option C is refracted, or option D is diffracted. So which option can be a correct one?
Radiated.
Okay, radiated, yeah. So power density is defined as a amount of the power radiated from the source per unit area. So it is usually measured watts per square meter. So correct option is option A. So power density is defined as a radiated power per unit area. Okay. So now next question is the power spectral density of a deterministic signal is given by this function, that is S sine F divided by F, where F is the frequency. Then the autocorrelation function of a signal in the time domain is, what will be the autocorrelation? Whether it is a delta function, option B a rectangular pulse, or option C a sine pulse, or D option A triangular pulse. So which option can be a correct one? Can you answer? So PSD of a deterministic signal. Yeah,
Basically, sine t by t means it is f. Sine f by f is it is like a sinc function,
yeah,
and
same.
if it is the square of the sinc function, if we will take the Fourier transform of that, then it will convert into the triangular function.
Yeah,
In
it
that way.
is the triangular function. Yeah, correct. So it is a option B. So power spectral density of a deterministic signal is given by this function that is also called as sinc, but here it is a square. So where f is the frequency, then autocorrelation of the signal in the time domain is a triangular pulse. It will be the triangular pulse. So Fourier transform of a sinc function is a rectangular pulse in the time domain, and if the Fourier transform the sinc squared function here, it is a sinc squared. So this is a triangular function in the time domain. So PSD is given by sine f divided by f whole square. So that corresponds to a autocorrelation function which will be the inverse Fourier transform of the PSD is a triangular. It will be the triangular in the time domain. It will be the triangular pulse. Okay, so now moving to the next question. A 4-point DFT of a real valued sequence that is given in x of 0 is to x of 1. It is not a 4-point, it is a 5-point. x1 is 3 minus 4j, x2 is 1, x3 is 1 plus 3j, x4 is 1. Then determine the energy density spectrum of the signal. So anyone of you have any idea how we can solve or how we can proceed with this question?
We have to take the mod of square of the each elements.
Yeah, mod of square of the each element. Okay, already we have seen the energy in the time domain as well as in the frequency domain. So it will vary from, I can take any, so n minus 1. So mod x of n whole square. If you are doing in the frequency domain, so x of k whole square, where k varies from 0 to n minus 1 ESD, or you can say energy density spectrum, or you can represent by E. So here we have k values. So it varies from 0 to 4, because here it is not a 4-point, it is a 5-point, because 4 numbers are given. Okay, so x k is square mod of it. So if you open this summation, you will get x of 0 mod x of 0 square plus x of 1 square plus x of 3 square plus x of 4 square to 2 is left. So here I am writing x of 2 square. So what will be the answer? Can you solve it? Are you solving?
41.
Yeah, 41 will be
41.
the. So it is a 2. So 2 mod of 2 square plus here x1 is mod 3 minus 4 square. So it is a mod. So we will solve. It is a complex number. So it will solve like this. 3 square, the real value plus imaginary. So 9 plus 16. So 25, root of 25, it will be 5 only. Or either you can write it mod of 25. So it will square, so again it will be 5. x1 similarly, 0 x1 x2. Now next 1 square plus 1 plus 3j square plus 1 square. Now it is a 4, and here we have solved. So 5 square will be the 25. Here 1 square. Similarly, you have to solve this one also. 1 square plus 3 square. So root of 10, it will be the root of 10 square will be the 10, right? Plus 1. So if you add all those values, you will get 41. So option B is the correct answer for this question. Okay. So I hope all of you are getting. So moving to the next question. Now next question is again a theoretical question now. So according to the Parseval's theorem, the energy spectral density curve is equal to option A, area under magnitude of the signal, option B, area under square of the magnitude of the signal, option C, area under square root of the magnitude of the signal, or option D, none of the mentioned. So which option will be the correct one? According to the Parseval's theorem.
I think B.
Okay. area under square of the magnitude of the okay. No. Okay. Okay, so already I have given there descriptions of what is the Parseval's theorem. That is what states that. So Parseval's theorem states that the total energy of a signal in the time domain is equal to the total energy of the signal in the frequency domain, and that is mathematically represented by this one minus infinite to infinite mod of xt square dt, and similarly in the frequency domain as well. Okay, so here xt is the time domain signal and x of f is a Fourier transform of frequency domain, or you can say the frequency domain signal of a xt, and the mod of x of f whole square is represented the energy spectral density. This both can represent the energy spectral density. So yeah, that is the correct area under square of a magnitude of the signal. So option B is the correct answer for this question. Okay. Now, next question is how can a power spectral density of a non-periodic signal be calculated? So, how we can calculate the power spectral density of a non-periodic signal? So, option A is by truncating, option B by integrating, option C by converting to the periodic signal, or option D is none of the mentioned. So, how we can calculate the PSD of a non-periodic signal?
We have to truncate the signal first.
Yeah, any signal we need to truncate it. So the PSD of a non-periodic signal xt, that is calculated by this equation, that is S of f, already we know that. Limit tends to infinite 1 by t xt of f square, where xt of f is the Fourier transform of the truncated signal xt, that is defined over the period minus t by 2 to t by 2. And that process is called a truncating, that signal taken over the Fourier transform, that is essential to calculate the PSD of a non-periodic signal. So option A. So power spectral density of a non-periodic signal is calculated by a truncating that signal over a certain period. Okay, so yeah, moving to the next question. Now next question is also a theoretical. So
Ma'am,
auto
third option cannot be applied. Means in other
uh,
case, we cannot convert into the periodic, and we can do the things, and we can get the spectral density.
what
Third option.
this one by converting to periodic.
Yeah, correct. This one.
No, if signal is non-periodic, how you can convert it into a periodic signal? Because periodic signal that repeats over a period of time, but signal is only already a non-periodic signal. So what we need to do, for example, this is a periodic signal, right? That is repeat over a period of time. But a non-periodic signal, I mean, we can't. I mean that repeat does not repeat that their pattern. So what we need to do, we need to just, I mean, divide it into a certain period and then calculate over this period. Okay, what is this? And what will be the PSD of this region? What is it in that case? Okay.
Okay.
Okay. Autocorrelation function of a periodic signal is equal to what will be the energy of the signal? Option B, power of the signal, or option C, its area in frequency domain, or option D, none of the mentioned. What will be the autocorrelation function of that periodic signal? Can you answer for this question?
It's a periodic. I think it's a power.
Yeah, it's power of that signal. Actually, autocorrelation function of any periodic signal that is represented by a power. That is represented by average power or power of that signal. So already we know that autocorrelation is a any signal is it is a it measures the similarity between that signal with its shifted version, or if there are two signals, that signal then shifted version to another signal. Okay, so xt and xt minus tau or t plus tau. So average power of that periodic signal is denoted by that is p, and look at the point 0 that is represented by rxx. It is the same signal, so that's why rx is autocorrelation. So limit tends to infinite 1 by t minus t by 2 to t by 2 x of mod of xt square tt. So it is represented by a power of that signal. It is called the power of that signal. So that's why option B is the correct answer for this question. Okay, so moving to the next question. Yeah, something you want to say? Okay, so next question is autocorrelation is a function which matches the two same signals, two different signals, one signal with its delayed version, or option D, none of the mentioned.
One signal with its delayed version.
Yeah, one signal with delayed version. So already we know the autocorrelation measures the similarity between the signals, but autocorrelation function actually one signal with its delayed version xt plus or t minus tau anything. But cross correlation actually measures the similarity between the two signals that can be xt yt minus tau. That is a cross correlation, and autocorrelation measures the similarity with the same signal. That is one signal with its delayed version. That is the option C is the correct answer. I think detailed description I have added in the next slide. Yeah, it is in the next slide. So it will be uploaded there and you can see. And autocorrelation also remember that it is represented by this function r xx of tau. Okay. So now, yeah, you want to ask something, Alex?
No, no.
Okay. So next question is the power spectral density of white noise is either it is a straight directional, or option B is multidirectional, option C is unidirectional, or D uniform throughout the frequency spectrum. What will be the power spectral density of a white noise?
Actually, amplitude is quite flat now for white noise. Then
Yeah,
magnitude also will be the uniform only.
yeah, the magnitude will be the uniform. So white noise already we have seen somewhere in the previous, I think first or two questions. For a white noise, it is a uniform. So white noise is a random. It is a random signal which having a equal intensity at overall frequency range, meaning the power spectral density will be the constant across the entire frequency spectrum. So this uniform distribution of the power is gives it the name white noise. That is analogous to white light, which contain all visible light frequencies in equal proportion, and it mathematically it is represented by this is a power spectral density of a white noise. It is representing that is equal to n naught divided by 2, where the S and NF is the PSG of a white noise, and not divided by is a constant or a uniform value. So option D is the correct answer for this question. The power spectral density of a white noise is uniform throughout the frequency spectrum. Okay. Okay. Moving to the next question. Next question is, if S of f is the power spectral density of a real wide-sense stationary random process, then which of the following is true? Always true. Option A, S of f must be greater than equal to 0, or B, S of 0 must be greater than equal to S of f, or option C, S of minus f is equal to minus S of f, and option D, minus infinite to infinite S of f df equal to 0. So it is related to properties of the power spectral density. Okay. So already we have seen that the power spectral density is always non-negative even function must be greater than equal to 0. So then power spectral density represents the distribution over the frequency. So since power cannot be a negative function, so PhD must be always a non-negative over all the frequency range. So in that case, that S of f must be greater than this criteria will be hold, and it will be the wrong option. And already we have seen that S of f must be equal to S of minus f. It will be the even function always. And so option A is the only correct answer for this question. Okay. Okay. So moving to the next question. Now next question is, the power spectral density of a real wide-sense stationary process is given by this function, that is Sx of f equal to 4 for mod f that is less than equal to 0, otherwise what will be the average power of that process. So how you will solve this question? So basically they are saying that the power spectral, that is PhD, has x of f at that it is distributed over minus 2 to 2. It is a f and the value is 4. Then what will be the average power of that process? So anyone of you want to solve this question? Please try at least once. So already we know that the average power, that is represented by P
It's
here,
8.
8. Okay, let's see. So formula is minus infinite to infinite S x of f df, right? So here the power is distributed minus 2 to 2, right? So here we will
16.
take minus 2 to 2, and their magnitude, that is S x of f function, is 4, right? 4 into df. So if you just integrate it, you will get 4 f minus 2 to 2. So 4 here to x plus 2. 2 minus minus of 2, right? So 4 into, if you add it, you will get 4. It will be the 16 here. Okay. So option D is the correct answer for this question. Okay. So have you got this question? It's not a 8. It will become a 16.
Yes, and actually that mod f was there, so
Yeah,
that
mod
time
f means
it was not
minus, and yeah,
minus f.
that minus f.
16.
Okay. Okay, so moving to the next question. Now, next question is, a random process is defined as x of t is equal to 6e to the power 80, where this a is a random variable uniformly distributed in the interval 0 to 2. Okay, then the autocorrelation function Rx T1 T2 is given as. So by which function that autocorrelation, that is T1 T2, is represented by? Option A, option B, C, or option D? So how we can proceed with this question?
I think here xt minus tau we have to take or plus tau whatever, and after that we have to change from T1 to T2 we have to take it.
Yeah, we need to take T1 as well as T2 also. So, okay, so xt is given as a 6 e to the power 80. Already we know that, and there is a random variable, that is a is uniformly distributed over the interval 0 to 2, right? So our x, that is we need to find t1 and t2. So here I am writing in the form of expectation of x t1 into x t2, right? This is the autocorrelation of these two functions. If we put now expectation of xt1 value, if we will put that it's a small t, so t1 we will take 6e to the power a t1 into 6 e to the power a t2, right? For xt1 we have to just take, if we are solving using this one, minus infinity, it will be the very large, and it is very, then it will difficult, because we have to just, we need to take the both the same way. So that's why we will solve by this, then after that we will put. Okay, so here expectation of, if we just calculate 36 e, what will be the a, t1 plus t2, right? We can write it like this, and this 36 will be the is a constant, so we can take it out. So expectation of e a to t1 plus t2. Now already we know that it is a uniformly distributed over the interval 0 to 2, right? 0 to 2. So what will be the magnitude of that? So now we can write it like this, 1 by 2, 0 to 2, and this function that is inside the, because it is uniformly distributed, t1 plus t2, and we need to take across where, because a is a random variable, so we have to differentiate, integrate it by a. Okay, because there a distribution will be given here, not in respect to a t. Okay, so we will integrate over a, so 36, that will be the 18 here, and if we further integrate it, so what we will get, e a t1 plus t2, right, divided by t1 plus t2 over 0 to 2. Now just we need to put the values, so e to t1 plus t2 divided by t1 plus t2. Now if we put a is equal to 0 here, so we will get minus 1 e to the power 0, that whole function will be 0, and there 1 divided by t1 to t2, right, t1 plus t2. So I'm writing here 18 t1 plus t2, that we can take a common t1 t2, so e to the power 2 t1 plus t2 minus 1 will be the left inside the bracket, right, because 1 divided by t1 plus t2 will be there. Okay, Actually, I don't have a space, so I just do it. Okay, so final answer will be the 18 divided by t1 plus t2 in brackets e to the power 2 t1 plus t2 minus 1. So option A will be the correct answer for this question. Okay, so have you understand this problem how to solve?
Yes.
Yeah. Okay. Okay, so moving to the next question. Now, next question is the autocorrelation of a signal is Rx of tau is equal to 10 sinc 2 tau. Then what will be the PSD? What is the PSD of that signal? So options are given. How we can solve this?
X of 0.
So already we know that the autocorrelation is Fourier transform of that PSD signal, and inversely also uh, that is Fourier transform to each other, right? So
Wiener-Kinchich.
so Wiener-Chinchin theorem. So already we know that what will be the Fourier transform of sinc function? Sinc
Rectangle.
a tau? No. How we can represent? Oh no, sinc tau. Sinc square tau. If it is a sinc square function, then it is a rectangular function, right? And if it is only one sinc, that will be the rectangular function. That is a rectangular in the frequency domain fy to a.
P by tau.
Okay, yeah, t by tau, or you can represent a f, because here it is given in the form of f. That's why I am writing fy to
Yeah.
a. Okay, so now given that autocorrelation of a signal Rx of tau is equal to 10 sinc 2 tau, then the PSD that is represented by S x of f in the that is a Fourier transform that signal that will be 10 tan 10 rectangular f by 2a. So here a value is 2. So 2 into 2, 4 will be there, right? Then PSD
Yes.
you can say. Then PSD. It is a Fourier transform of that. Okay. So which option will be the correct one? 10 rectangular f by 4. So that is the option B is the correct answer for this question. Okay. Okay. So I hope you understand this question. Now moving to the next question. Now next question is if xt is a signal applied as input to a LTI system with impulse response st, that is impulse response is given, the output of a system is yt. So then value of yt at t equal to 5 is, there is a basic convolution question. So already we know that minus infinite to infinite yt is equal
Why,
to
why, why?
uh,
Sorry.
okay, please mute yourself. So it is a xt h t minus tau, right? This is a convolution operation, convolution of a two signal. So if two signals are given, so how we can find out the output? So it is like this. So xt and st is given, then we need to find out yt at t equal to 5. So how we can find out, or either you can write it like this also, ht x t minus tau also. And here you can say that xt is a unit step function, right? Because it is a t only one like this till it is not defined, so that means that is infinite. So xt is equal to ut. We can say that, right? So if we need to find out y t, so we can write minus infinite to infinite h of t x is u t minus tau, right? Or h of tau it is actually. It is a t minus tau. And at y is equal to 5, we need to find out. So minus infinite to infinite h of tau u 5 minus tau, right? Or if you are not putting, so you can say that x of 5 minus tau. So first we need to find out u 5 minus tau, right? So first we need to take the inverse. Already we know that x of t, just x of minus t, so it will be the like this, right? U of xt we can represent it, and it is a 5 minus tau, so it will be the 5 here, 5. So it will represent this one, 5 minus tau, and st is already given. So now if you want to find y of t at t is equal to 5, that is, just take the convolution of these two, this one and this one. So here you can say that it is going from 5, so here it will vary from 5 to minus 10, no, or it is a minus 10, so here it is a negative value, so minus 10 to 5, right? And their magnitude is 5 if you multiply 5, right? 5 d tau. So 5 tau minus 10 to 5. If you integrate it, just put the value 5 minus minus of 10, so you will get 5 into 15, so you will, if you multiply, you will get 75, right? So y of t value at t is equal to 5, it is a 75. It is a simple convolution, okay, of the two signals. Okay, so have you got this question? Can we move to the next? Just we have to just take a x of tau, then x t minus tau. Okay,
Oh,
okay, so moving to the next question. Now next question is consider a random process yt that is defined by xt minus xt plus tau, where xt is a stationary non-periodic process and tau is a constant. And if Rx of tau is the autocorrelation of a random process xt, then variance of yt will be. And what will be the variance of yt? So how we can solve it? Any idea? What answer can be? So here yt is given as a xt minus xt plus tau. Okay, and already we know that some concepts writing here, we know that expectation of x of t square, or you can say xt square, is equal to Rx of 0. We have seen in the theoretical or in the properties of the VSD and autocorrelation. And similarly, expectation of an output signal must be equal to 0. That means if xt is a stationary, then yt will be the also a stationary random process, a stationary non-periodic process. If xt is that already here it is written stationary non-periodic, then yt will be the also a stationary non-periodic signal. Okay, so from there E of yt will be equal to 0. Okay, and how we can find out a variance? Variance of yt, or you can represent it by a sigma y, right? That is equal to E expectation of y square t minus expectation of yt square whole square. Okay, so already we know that it is the same, so it will be the 0. Expectation of yt is a 0, so expectation of yt square will be the 0, so this function will be the 0. Now we need to find the expectation of y square t. So if you further yt is equal to xt minus xt plus tau, right? Just put the value and square it. Xt minus xt plus tau whole square, right? Now we need to open it. So expectation of x square t, that is a square, right? Plus expectation of, just I am opening it, x square t plus tau minus 2 expectation of xt into xt plus tau, right? Just a minus b whole square, just open it. Okay, here I can, so here this function xt, it is a xt is a stationary random process. So already we know that xt, it is a, it is a, what will be the, it is a autocorrelation function xt into xt plus tau, right? It is a autocorrelation of xt, so we can, just a minute, we can represent this xt into xt plus tau by rx of tau, right? It is a simple autocorrelation, so we can represent this function rx of tau. Okay, so I am removing from here so that I can write. I hope all of you have noted down. So after there I am just writing here. So variance will be, so expectation of x square t, already I have written that expectation of x square t or expectation of x square t plus tau, it does not vary, does not matter, either it is a shifted version, it is equal to rx of 0. Okay, because it is equal to at autocorrelation at a point of 0. So here we can write it this one, rx of 0 plus, we can also write expectation of x square t plus tau also, rx of 0 minus, here it is a 2 rx of tau, because it is a autocorrelation of xt and its shifted version, right? So sigma y, here it is a sigma y, that is variance, it is a 2 rx of 0 minus 2 rx of tau, right? Now if you take 2 out or common, you can say rx of 0 minus rx of tau. Okay, so which option is the correct one? After this solving it, option C is the correct answer for this question. So have you understand this question?
Yes.
Yeah. Okay. So moving to the next question. Now, next question is a zero mean random signal is uniformly distributed between limits minus a to a. Okay. That means it is a zero mean and uniformly distributed. So it is a uniformly distribution minus a to a. So what will be the that magnitude? That is 1 by 2a. It is because it is a uniform distribution. Okay, it is a x. So a zero mean random signal is uniformly distributed between minus a to a, and its mean square value is equal to its variance. Okay, its mean square value is equal to its variance. Then the RMS value of the signal is what will be the RMS value? So anyone of you have any idea how we can solve it now?
Same whatever previous one we solved, no? Variance is equal to expectation of x square t
Yeah,
plus e of x t whole square. That we have to find, like variance is given, we have to find the mean square e of x square
yeah.
of that
There is
thing.
other formula also for variance. That is already we know that minus infinite or infinite any value. That function x square p of x, right? Or f of x dx. Variance is also denoted by this one, right? So it can be
Yes.
represented by that expectation form or this integration form also. Similarly, mean is also is represented by mu. Already you have studied with minus infinite to infinite x p of x dx for random signals. This is a mean, this is a variance. Okay. So by this formula from here we can, here it is a uniformly distributed between minus a to a. X square we don't know. Px value is 1 by 2a into tx. Okay. So here we need to take 1 by 2 out because here integration is with respect to x only, right? So minus a to a x square dx. Now if you further do this, so what we will get, x cube divided by 3, right? Minus a to a. Now you can just solve me and let me know what can be a value. 1 by 2a into a cube divided by 3, in brackets I can write it, and minus, so minus will be the plus a cube divided by 3, right? So here what is this? So 2a cube divided by 6 we will get, right? So it will be the cancel out, 6a will be the, so here you will get a square divided by 3, right? And there then they have asked the mean square value is equal to its variance. So its variance we have got, then we need to find then RMS value of that signal. What will be the RMS? So root mean square of that variance. So PRMS is equal to that root of variance. So root of a square divided by 3. So if you just a by root 3. Okay. So a by root 3. So option 1 is the correct answer for this question. So have you understand this question?
Yes.
Okay. Okay, so moving to the next question. And now next question is, consider a signal is given as xt is equal to 10 sine 2 pi 100t for t varying 0 to 1 and 0 elsewhere, where t is in second. Then the energy of that signal is, what will be the energy of that signal? Here they have asked what will be the energy of the signal. So can you solve this question?
Yes.
So just please take 1 minute time and try to solve it. Then I will solve it. What value can we have? So okay, xt is given as 10 sine 2 pi 100t. Okay, xt is given as, then how we can calculate the energy of that signal? Energy of signal
Minus infinity mod of xt square.
is calculated by minus infinite to infinite x of t whole square, or you can say mod of t whole square dt, right? But here it is varying from 0 to 1 and 0 elsewhere. So 0 to 1 we have to take only, and xt square. So xt is given as 10 sine 2 pi 100t whole square dt, right? Now if you open this 0 to 1, 100 sine square 2 pi 100 t dt. Okay, so here we directly cannot calculate the sine square function. So what is the sine square theta? Sine square theta, that is equal to 1 by 2 1 minus cos 2 theta, right? So you can put this here. So 0 to by 1, 100 divided by 2, here 1 minus cos 2 theta. Theta is this whole function, right? So 4 pi 100 t dt, right? Now we can, so it is a 50, so just 50 minus 50 cos 4 pi 100 t dt. Now we can integrate it. Okay, so if you integrate it, you will get 50 t here and here minus 50 cos, integration of cos is sine, right? Sine 4 pi 100 t divided by 4 pi 100, because we are just integrating with respect to t and 0 to 1, right? Now just put the values of t. So here if we are putting 1, so 50, and here also if we are putting the t is equal to 1, so it is a sine 400 pi. So if you solve it, you will get the value 0, and if you put t is equal to 0 here, so minus 0 will be there, and here if you put 0, so again you will get 0 only, Okay, so minus minus, yeah, this one is plus. So 50 will be the final answer. Okay, so that's it. Option 4 is the correct answer for this question. Okay, so have you understand this question how to solve? So have you solved this question? Are you solving?
I solved earlier.
Okay, got this question? Got it?
Yeah, ma'am, got it.
Okay, okay. So moving to the next question. Our next question is a time domain signal is defined as xt with an energy signal is equal to 50 joule. Then energy of the signal 5x x of 10t minus 10 is equal to. If energy of that signal xt is given 50 joule, right? This is energy of a xt is given. Now we need to find out the energy of this 5 x 10 t minus 10. What will be the energy of that signal? Okay, so energy of signal is given as here x of t is E. Energy of that signal is, let's E is 50 joule, here it is given. Then energy of what will be the A x of t, that is equal to A square t, right? Energy of that A is AXT. And similarly, what will be the energy of A x B T plus or plus minus C, you can say. What will be the energy? So if you calculate it, so you will get A square E divided by B. So in the properties that Fourier transform or you have must be studied about, what will be the energy. So energy of that this function will be A square E by B. Similarly, now we need to find out energy of 5x 10 t minus 10. So it will be the equal to A square. A square is 5. So 5 square. So 5 square. E is already given is 50, right? Energy of that xt is 50 is already given. So we need to find out a 5 with 5 and the shifted version of that xt signal by B. B is given as 10. This one 10. It is a B. It is a. It is a C value. Okay. So this will be the cancel out. You will get 125. Okay. So have you understand this question? So how to calculate the
Yes.
energy of that shifted version of any signal? Already xt energy of xt signal is already given. We need to find out the signal of 5x 10t minus 10. That means shifted version of that xt signal. So from the properties, if energy of that signal is given E, then what will be the AXT energy of that AXT signal, that is A square E. Similarly, we can find out AX BT plus minus or C signal, that is A square E divided by B. Okay, so in this way you can calculate it. So it is a 125. Okay, so I hope you understand this question. Now moving to the next question. Now next question is also related to this. If energy of a signal GT is given 16 joule. Energy of that signal GT is given, that is 16 joule energy. Here. Then find the energy of the signal Ft in joule. That F signal is given as GT is equal to 4 F40 plus 9 plus 2 Ft by 2 plus 16. So here energy of that signal GT is given. We need to find out the energy of Ft. So it is all here, the Ft shifted version of Ft is given. So same way, what is the energy of that Ft? It is a E. Let's assume that the energy of signal Ft is E. Then what will be the energy of F of At? Sorry, Fa, Ft, that is A square E, right? And what will be the energy of F of At? So it is A by E by A. Energy of signal is Ft divided by A. It will be the denominator. Okay. Now function is given as a Gt is equal to 4f 40 plus 9 plus 2f t by 2 plus 6. So energy of that Gt is given already, that is a 16 joule, right? And it is a 4f40 plus 9. So already we have seen that. So A square E, that means 4 square E divided by 4. Divided in the previous we have seen that one. What will be the value of that energy? So A square E by B. Similarly, 4 square E energy of that Ft divided by B. This is a 4. Similarly, here also A is 2 square E divided by A. A, it is a T by 2. So it will be the 1 by 2. Okay. So here 16 joule equal to 4E, because 1 4 will be cancelled out. So 4E plus 8E. So 2 to the 4 into 2, 8E. Okay. So 16 equal to 12E. So E will be 16 divided by 12. It is a 4 by 3. Or you further solve it, 1.33. You can represent it in a joule. Energy is represented by in a joule. So here what we have assumed, E. E is the energy of the signal f of t. So they have asked find the energy of the signal ft. So that is energy of the signal ft is represented by E, and E is equal to 1.33 we have got. So energy of the signal ft is 1.33 joule. Okay. Okay. So have you understand this question? How to solve? Okay. So moving to the next question. So I hope you have noted down. Just a minute, please. So next question is, a signal ft has energy E. Then what will be the energy of that signal f of 2t? So already here told you, if ft has energy of E, then f of 2t, the energy of that signal is E by 2, right? E by A if it is there. So option 2 is the correct answer for this question. Actually here it is just not removing from here, and I was trying. So are you able to see this question and options also?
So I think next questions it will go. What is it?
In the next question it is going, but in this question it is not going. I don't know. In this question, for question number 20, I was asking. So it is a straight, if energy of that signal is given, then they are asking what will be the energy of f of 2t. So it will be the e by 2. Okay. Okay. So now this question, the signal energy of the continuous time signal xt. What will be the signal energy of this continuous time signal xt is given. Okay. So how we can solve it? Just simply, already we know that energy of the signal is represented by E, that is the formula is minus infinite to infinite x square t dt, right? Just we need to square it, open it and square it. And also you can say that the xt is represented by t minus 1 ut minus 1 minus t minus 2 ut minus 2 minus ut minus 3 minus u into ut minus 3 plus t minus 4 into ut minus 4. So we can represent in the it is a given in unit step function, right? We can represent it in another, that ramp function also, t minus 1 ut minus 1. So xt is can be also represented by rt minus 1 minus rt minus 2 minus rt minus 3 plus rt minus 4. We can represent this function in this way.
Yes, ma'am.
Okay, so can you plot this xt also? T here xt. So it is a whole ramp function. Okay, so it is a t minus 1. So that means it will start from at minus 1, it will a ramp function, then another one will be at, so it will be go straight because it start from 1 to t. So now next one is straight, then again at 3 another ramp function will add, so at 3 it will go down. So if you plot it, you will get this type of function. So it will be 1 2 3 and 4. Okay, if you plot this one. So now from here you can calculate it. Okay, so energy is equal to, so from 1 to 2, 1 to 2, it is a ramp function, that is t minus 1 whole square dt plus 2 to 3, 2 to 3, it is a straight, so the value is 1 only, it is a 1. So it is a energy, so we are just 1 square dt plus it is a 3 to 4, again the negative ramp function, so 3 to 4, so you can say that minus t plus 4 because it is a downward, so minus t will be there, whole square dt. Okay, now if you open it and then take a integration, so 1 to 2, so you will get t square plus 1 minus 2t dt here also, so 2 to 3 1, you can say that dt directly plus 3 to 4, so just I am removing it from here, and now it is not required, so I am removing it. I hope you all of you have noted down. So plus, so t square plus 16 minus 8t, right, dt. Okay, now we can integrate, we can integrate it. So it will be the t cube divided by 3 plus t minus 2t square divided by 2, right? It will vary from 1 to 2, plus here it is a t, that is 2 to 3, plus here t cube, again t cube divided by 3, plus 16t minus 8 t square divided by 2, that will vary from, the integration is 3 to 4. Okay, so now just put the limit value. So first, if we are putting 2 here in this one, so 8 divided by 3 plus 2, here 2 will be the cancelled out, so minus 4 will be there for this one, then minus 1, this part, so 1 by 3 plus 1 minus 1, right? Now for this one, so plus 3 minus 2, only one function is there, so 3 minus 2. Now next one is 64 divided by 3, so here we are putting 4, 4 4 are 16, 16 4 are 64 divided by 3, plus here again 16 into 4 will be 64, here 2 4 are, so again here it will come minus 64, right? We are putting 4 in this. Now put 3 in this equation, so you will get 27 divided by 3, or we can write it directly 9, because 27 divided by 3 will be 9 only. So 9 plus 16 into 3. So how much it will come? 16 into 3 is 48, minus again here. So 3 3 are 9, 9 4 are 36. Okay, so just this will and this will cancel out, this will cancel out. Just you add and subtract all those things, you will get first this one by 371 divided by 3. If you do that and then if you add all those things, so you will get 22. If you further do, you will get 5 by 3 here. So that energy of this signal is 5 by 3 you will get. Okay, so option 4 is the correct answer for this question. Okay, so have you understand this question, how to solve?
Yes.
Okay, so moving to the next question. Let us, so just a minute, I'm closing it because it is not going, otherwise I cannot able to solve this question. So just a minute. So now you can able to see. Hello.
Yes. Now okay, ma'am.
Okay, okay. Okay, so now next question is what is the power of the signal xt, that is equal to 8 sine 2 pi t plus 4 sine 4 pi t. So this is a basic questions related to the energy and power signal in the first week video lecture. So can you solve it?
Yeah, P is equal to A square by 2. Both A square by 2 will.
Okay, yeah, right. The power of that any signal is calculated by a square by 2. So here the two signals are there, 8 sine 2 pi t plus 4 sine 4 pi t. So just we are taking the p1, that is a1 square divided by 2, and the p2 is equal to a2 square by 2. So here a1 is 8, so 8 square divided by 2 p1, and the p2 is a2 is 4 square divided by 2. So p1 you will get 32, and p2 you will get 8, right? And the overall power we can represent it like P is equal to P1 plus P2. So 32 plus 8 we will get 40. So overall power is 40. So option 1 is the correct answer for this question. Okay. Okay, so moving to the next question. Now next question is, for a signal y of n is equal to e to the power j pi by 2 n plus pi by 2, which one of the following is true? So option 1 is power of the signal is infinite, or option 2 is power of the signal is 0. Option 3 is power of the signal is equal to 1 and energy. Option 4 is energy of the signal is equal to 0. So which option can be a correct one?
Is it C?
Yeah, it is C, but how? The power of the signal is equal to
Actually, ma'am,
1.
it is e to the power j theta, na? So I saw it like another way.
Mhm.
Theta. After that, I put the value, and it is cos 90 plus theta plus j x sin 90 plus theta. Then
Okay.
I saw it in that way itself, and then I have taken minus sin pi by 2 n plus j cos 2 pi by pi by 2 n, and n is j cos pi by 2 is 0. Then sin pi by 2 n came, and there is a, that is a periodic type of thing, and a is equal to minus sin pi by 2. Then it will be always come as a 1 only, because n will be integer. No?
Yeah. So, okay, so already we know that this is a periodic signal, right? So how we can check the periodicity? That is, we know that n is equal to 2 pi by omega, right? So 2 pi by omega is here, it is a pi by 2. So it is a 4. That means it is a periodic signal, right? Now, already we know that what is the power of that signal? Any signal of a is represented by 1 by n in a normal energy and power, that basic formula. So here you can
Minus
say that
3 by
n is equal to 0 to n minus 1 mod of y1 yn square, right? It is represented by this one. So if you calculate here mod of yn, so for e to the power j pi by 2 n plus pi by 2, what will be the value? Always for this equation it will always be 1, right? So if you put here 1 by n, where n varies from 0 to n minus 1. So 1, it is 1 square is 1 only, and here the summation is varies, that is 1 is represented to n times. It is a summation, so if you write 1 plus 1 plus 1 till n, right, till n, so we can write it like 1 by n into n. So n will be the cancel out, that is 1. So power of the signal is equal to 1 always. So that which way you have solved, that is also correct, and in this way you can also solve. Just check whether it is a periodic signal or a aperiodic signal, then just put in this equation. Okay.
Okay.
Okay, so I hope you have understand. So moving to the next question. Now next question is determine the average power of the signal xt, that is cos 2 pi f naught t, where f naught is a fundamental frequency and t indicates continuous time domain. So how we can solve it? So xt power average, we need to find out the average power of that signal. So signal is xt, that is equal to cos 2 pi f naught t, right? We can also write this 2 cos omega naught t, right? And p average, we know that it is find out by 1 by t 0 to t x square t dt, average power of any signal. Okay, so now 1 by t, put the value of xt, so it is a cos square omega naught t dt. Okay, so already once I have explained that what is a cos square theta, that is 1 by 2 1 plus cos 2 theta, right? So just put it here, 1 by t 0 to t 1 by 2 plus 1 by 2 cos 2 omega naught t and dt. Now we can integrate it. So 1 by t and in brackets, so 1 by 2 t plus 1 by 2 sine 2 omega naught t divided by omega, sorry, 2 omega 0 to t. Okay, so 1 by t in brackets 1 by 2 here t in place of it. So if you put here t, so that is not a any signal, so that will equal to 0. Similarly, if you put 0, so all these values will be the 0 only. Okay, here put, if you put sine 2 sine 0, so here t will be the cancel out, so 1 by 2 only left. Okay, so 1 by 2, that means 0.5 watt you will get. So from here you will get option 4 is the correct answer for this question. Okay. Okay, so moving to the next question. Now next question is consider a discrete time signal x1 n, that is equal to a to the power n un. Identify which of the following is the correct statement. Which one of the following correct statement related to this one, x1 n is equal to a to the power n un. So they have said that it is a low frequency signal for -1, a varies from -1 to 0, or either it is a high frequency signal for varies from a varies from 0 to 1, and option 3, for a is equal to 0 it will represent band pass signal, or it is a frequency domain representation that does not exist for mod of a must be greater than 0. So here it is given as x1n is equal to e to the power n u of n, right? If you find out the z transform of that x, so x1 of z must be equal to 1 by 1 minus a z inverse, the z transform of that signal, or we can write it z divided by z minus a, right? Z transform of this x1n. We can write it. And where ROC is must be z, it is greater than equal to a, right? So if we plot it, so like this, okay, it is a real and it is an imaginary part, imaginary. So it is said that it is a low frequency signal from -1 to 0. So it is it is not related to, it is not a low frequency signal. And similarly, it is 0 to 1, it is not a, because a it's not defined. And for a is equal to 0, it will represent a band pass signal. If we put here a is equal to 0, so it is a z divided by z. So that is 1. That is equal to 1. So for a, if it will represent the band pass signal, so a must be equal to 1. That function must be equal to not a 0. Okay, so this one is also incorrect. The frequency domain representation does not exist for mod of a. So that is called that mod of a, that frequency domain representation does not exist. That is true here, because frequency domain representation is represented by only this circular. The system is stable and unstable in that case. So that's why option 4 is the correct answer for this question. Okay.
Can you explain again, ma'am?
Okay, so they have said it is a low frequency signal for -1 to a varies here.
Please, fourth option. Fourth
Hmm,
option.
4 options. So okay, frequency domain representation does not exist for mod of a greater than 1. So that circular representation, that ROC will represent only for 1. It is a 1. You know that it is a -1, 1, 1 minus 1, right? Already we know that that is a unit circular for a discrete time ROC representation.
Yes.
So mod greater than 1, that means minus a, and that is plus a must be greater than 1. So outside greater than 1 means that is this side and this side. That is said that frequency domain representation does
Got it.
not exist. It is not existing, right? So
Got it.
that means that is the correct one. The following statement is correct in this sense. Okay. Okay, so moving to the next question. Now next question is, if the that is PSD, it is represented as PSD as x of e to the power j omega is equal to 1. For omega varies from minus pi to pi, what is the power of the discrete time signal? What will be the power of that discrete time signal? So power of any discrete time signal, we know that is represented by 1 by t, or here it is in terms of pi. So pi, so we can say that 2 pi is a minus pi to pi sx e to the power j omega d omega, right? Power of any signal. So it is a 1 by 2 pi. Here omega already varies minus pi to pi only. And what is the value of x e to the power j omega? Already given 1 d omega. So if you just solve it, you will get pi minus of pi, right? So 1 by 2 pi into 2 pi, that is equal to 1. So option B is the correct, and the power of that discrete time signal is 1, which PSD is represented 1 from omega varies minus pi to pi. Okay, so moving to the next question. Now next question is, a periodic for a periodic signal that is represented Vt, that is equal to 30 sine 100t plus 10 cos 300t plus 6 sine 500t plus pi by 4. What is the fundamental frequency in radian per second, not in hertz? They have asked in omega form only. Omega is represented radian per second, right? So what will be the fundamental frequency? So what is the frequencies other? So omega 1, what is it? It is 100, right? Omega 1, omega 2 is 300 and omega 3 is 500. This one, right? So what is a fundamental frequency? So fundamental frequency, let's say it's omega naught. It is a HCF of omega 1, omega 2 and omega 3. So HCF of these two, 100, 300 and 500. What will be the HCF of that one? 100. What will be the common factor of these three? Can you tell?
100.
Yeah, 100. So fundamental frequency in radian per second is 100. Fundamental frequency, that is omega naught. So option 1 is the correct answer for this question. Okay. Okay, so moving to the next question. Now next question is the result of the convolution x of minus t convolution of del minus t naught. What will be the result of this convolution? Can you answer at least this question? Which option can be a correct one? This is the properties of the convolution. So if any signal is convolved with the delta function, that will be the same shifted signal, right? So x minus t naught. It is the properties of delta function as well as convolution. If any signal that will be convolved with the delta function, that signal with itself, that the resultant signal will be the itself, that signal with that shifted version. Okay. So option 4 is the correct answer for this question. So have you got this question?
Yes.
Okay, so now next question is the condition for periodicity of a continuous time signal is. What is the condition of periodicity? Can you answer this question? Please answer this question. What is a condition of periodicity in the continuous time signal? Option 1 is xt is equal to xt plus t naught, or option 2 is xt equal to 1 divided by
First.
xt. Yeah, first. The condition of periodicity is condition for periodicity is equal to xt must be equal to xt plus t naught. Okay, so that means it repeats over a time. Okay, so now next question. Next question is, which of the following is not one of the representation of a discrete time signal? So which of the following in the from the options is not a discrete time signal cannot be represented? Option 1 is sequence representation, option 2 is graphical representation, or option 3 is analytical operation representation, or option 4 is tabular representation. So they are asking for discrete time signal. So discrete time signal is in which form? That discrete time signal, that let's say it is x of n is any signal. For example, 1, 4, 5, 3, right? It is called a sequence representation. So that means discrete time signal is represented in sequence form. Also graphical form, already we know that we can represent the discrete time signal in this way. So at the 0th position, it is a 1, and at 1 position it is a 4, and at second position it is a 5, and its third position is a 3. So It is a graphical representation of any discrete time signal. It is a graphical representation. The graphical representation. So that means, and next one is a tabular. So what is a tabular? That is 1 and it is a x of n. So that can be represented in the tabular form. So n is very 0, 1, 2, 3. So at 0th position, what is the value? It is a 1. At 1, it is a 4. It is a 5. It is a 3. So it is a tabular representation. So discrete time signal is can be represented in the sequence representation, graphical representation, and tabular form, but not in the analytical representation. So option 3 is the correct answer for this question. Okay. So now moving to the next question, and I think last question for this week. So a wide sense stationary process xt with power spectral density Sx of f is equal to 2. Constant for all f is passed through a LTI system with impulse response is given as st sync 2t. What is the power of the output process yt? So how we can solve it, or how we can further proceed? So power spectral density is given Sx of and St is given. Okay. So there is a one formula for output PST, that is Sy f, that is equal to mod h of f square Sx of f, right? To find out the power output PST if the impulse response and input signal is given. Okay, and Ht is given as a sinc 2t, right? Then what will be the Fourier transform, I mean, of that sinc function? So already we know that this, so it is a rectangular function. The Fourier transform of St is rectangular f by 2a, so 2f by 4, right? Fourier transform, we can say that it is a Fourier transform of Ht, right? So we have got that h of f Sx of f is given as a 2, right? So we can say that SYF, that is rectangular f by 4 whole square, that is into 2. So 2 into rectangular square f by 4, right? This we have got Sy of f, but here it is given in this form. That means we don't denote rectangular form. So now total, so we have to integrate it in order to find out the total power. The total power, that is minus infinite to infinite s x of f df. Okay, so minus 2y,
Xy.
yeah, y, sorry, y. So it is varying from, it is a rectangular function, and here f is 4, so that means it will vary minus 2 to 2, right? 2 to 2, so minus 2 to 2 into, and there is 2, so 2 into tf. So if you further do this, so 2 plus 2, we will get 8, right? So option D is the correct answer for this question. Okay, so this is a formula, basic formula. I don't know whether that formula have been covered in this video lectures or not. This is a one formula, relation between the input PSD, impulse response, and output PSD. Okay, so if input impulse response is given in this form, just take a Fourier transform of that function, then put in this equation. If it is in a check with the options, if it is given in this form, then you can take it Otherwise, then just integrate because it is a that in rectangular form. The function is given, so just you need to change it function, that function first. Okay, then calculate. Just integrate over the area under that curve. Okay, so option B is the correct answer. So for this week, that questions have been completed. So I think there are two lectures only in this week. So mostly I have taken that energy and power related question and some questions related to basic, which we can recapitulate in the previous one. Okay, so now questions have been completed. If you have any doubt, you can ask. Otherwise, we can close the session. So yeah, thank you everyone. Thank you for joining this session. Yeah, if you have any doubt, now you can ask.
Ma'am, actually one question was given in week 12
Week
in
12.
assignment.
Okay,
That question is, ma'am, we have to find the normalized discrete frequency
normalize
that
this.
was given. Frequency omega we have to find. Fs was given 12 kilohertz
Okay,
and XAT was 23 into cos 70 to 100 pi t.
okay,
Then that normalized discrete frequency we have to find, and there my answer was coming different from the options. And in previous assignments also, a lot of problems we faced with the options as well. So
yes, that I
can
know.
you check once and please re-evaluate that assignments, ma'am, because our marks will be depend on that.
Okay, okay. Actually, that problem has been raised previously also. With I think week 7 or 8 something. So if there is a in mistake in assignment questions or assignment option, that can be given. Or one thing you can do, you can raise I think question in that forum, discussion forum. From there we can see that and they will see that. Otherwise, from there they can see that and they can, I mean, just raise a doubt in the raise a question in the discussion forum related to that assignment. Because here I cannot take that current assignment questions itself.
No problem, ma'am. But
Hmm.
uh, it is not. You can check the question and answer forum. There we raised a lot
Okay.
of questions. Nobody is replying.
Oh no, this is okay. Okay, I will check, and once I will meet them, then I will also just.
I think we raised all the questions, all the problems there. No one
Okay.
is replying there. And also we
Okay.
raised with sir when last time he came to the YouTube
Live.
live.
Yeah.
But I think nothing happened after that. Please check once. I hope you will see.
Okay, okay, that is not a problem. If question or options are mistaken or given wrong option, that grace marks you will be given. Okay, so the grace marks will be given if there is a any problem with the questions or options. I will also go personally and ask them if, there. Otherwise, I will. Okay, I can answer also. Okay, I will check it once.
Yes, ma'am, please, ma'am. And also please check the question and answer forum. That is your discussion forum.
Yeah,
Please
yeah,
check a
yes.
lot of questions are there. Nobody is replying there.
Oh, okay, okay, I will check it.
Thank you, ma'am. Thank you so
Okay,
much.
okay. So thank you everyone. Thank you for joining. Now,
Yeah. Uh,
yeah.
Ma'am, Anish here. Yeah. Ma'am, just want to tell you that, just thank you for conducting all these week's classes. And these classes were very, the explanation was very sufficient. It helped a lot for us doing our assignments.
Okay. So that is actually our purpose to it is help you solve some I mean same type of questions so that can be helpful to solve your assignment problem. So it is helpful for you guys
Yeah.
solving
Yes, ma'am.
assignment. Okay, so that is fine. And okay, so this is the last week I think. Now the questions and everything have been completed. So please all the best to all of you for
Yeah.
your
Thank you, ma'am.
exams.
And yeah, and very big thank you for you also.
Okay, yeah, thank you, thank you. So thank you everyone.
Thank
Now, if you don't have any doubt, so we can close this session.
Yes.
Okay, okay. So thank you. You can leave the session then. We'll proceed further. Okay, so thank you everyone. Thank you for the joining. The questions have been completed. Now maybe so all the best for the exam.